Welcome viewers. In this lesson we want to consider some of n terms of geometric progression. So when we have a geometric progression, we have geometric progression or exponential sequence. When this sequence is being generated by multiplying terms or multiplying the terms of such sequence by a number to generate the successive term by a number which is called a common ratio. Or we divide terms to generate the successive term by a number which is known as a common ratio. And that is simply what a geometric progression is. So we say we have geometric progression when Tn equals to ar raised to n minus 1. While our Tn is the nth term of a geometric progression. Our n is greater than or equals to 1 and n is subset of the natural number. That is n are positive integers. Also, then our a is the first term and r is the common ratio. Now, we are talking about sum of nth term. That is our T1 from here now. T1 will be AR. Our T2 when n equals to 2. That is AR raised to 1. Sorry, T1 is AR raised to 0, which is A. Our T2 will be when n equals to 2. So 2 minus 1, that is AR. T3, AR square. And our Tn equals to AR raised to n minus 1. So these are the terms of a geometric progression. So now their sum, which is denoted with letter Sn, equals their sum now. So this is the first time A plus the second time, which is AR, plus third time, which is AR square, plus the next one AR raised to 3, plus until we get to the n term, which is AR raised to n minus 1. So this is the sum, and this sum is also what we call the partial sum of geometric progression, which is known as series. That is what we call geometric series. So this is what we call geometric series. So partial sum of geometric progression, or we call it geometric series. Now, suppose we have this. If we multiply this by r, we are going to have RSN. We are multiplying everything here by r now. So this one will be AR plus AR square plus AR. Now the r will increase to the power of 3 plus AR to the power of 4 plus AR raised to n. Because by the time you multiply this by r, you have r raised to n minus 1. They multiply by another r. By rule of indices, that is just r raised to n minus 1 plus 1. Minus 1 plus 1, that is just a r raised to n. So that's why this will turn to this. Now, if we find the difference of this, we can find the difference in two ways. It's either we subtract this from this, or we subtract Sn from Rsn, or we take Rsn from Sn. Let's consider the two cases. Let's subtract. If you subtract, we are going to have a Sn minus Rsn equals, A minus, these two we minus, these two we cancel out. This will also go, this will go. The R4, if we introduce this, AR raised to 4, this also will go. So this one will also go. Before this term, there is AR raised to n minus 1, then AR, then plus AR raised to n. So by the time we do that, these two will go. So what will be left is just A minus AR raised to n. That is what will be left. Here Sn is common, so you can take out Sn, so that you have a 1 minus r equals to, here also you can factorize out a 1 minus r raised to the power of n. Now to make Sn subject, now we divide both sides by 1 minus r. So doing that, we have a Sn equals to a bracket 1 minus r raised to the power of n divided by 1 minus r. So this is the n term, sum of n term of what? Of geometric progression. And we have this formula when our r is less than 1. You know, for us to take a value from 1 and get a positive result, it has to be less than 1. So we say we have this formula when r is less than 1. Also, let's consider the second case now. If we are to take this Sn from Sr now, so you know we have this minus this. So we have Rsn minus Sn. We want to take this upper part from the lower part. The same case, the only difference will just be everything, all this will stay minus out. So what will be left is Ar, this power of n minus A. This is what we have. Now factorize out Sn. So we have Sn, open bracket, r minus 1 equals to, A is also common here, A open bracket, r is power of n minus 1. Now, make Sn subject again with divide both sides. So we have Sn equals to A r minus A open bracket, r is power of n minus 1 divided by r minus 1. So we have this case when our r is greater than 1. So for us to take 1 from r, it has to be greater than